Introducing Polyrhythm Peruser, an application for learning and training polyrhythms. A common polyrhythm is a group of 3 against a group of 2. To start, you can toggle on and off the different groups. Consider only looking at the group of 3. Or vice versa, looking only at the group of 2. Then, you can put the groups together and get a feel for how they sound at the same time. Play along to the rhythm using the keys T and N and get live feedback for your accuracy. Hover the mouse over various UI components to get help on how to use them. This tempo box sets the speed to whatever you would like. An additional way of setting the tempo is by tapping the pulse in the tap tempo box. Click on the settings icon to explore the various preferences. You can change the input key, enable an automated tempo mode, deactivate the streak feature, and even set the volumes and notes of the various voices. So, how does Polyrhythm Peruser work? Well, there are 3 main files: app, app UI, and synth. And of course, we are using CMU 112 graphics. The modules that we are using are PyAudio and NumPy. Let's first talk about app UI. App UI is how all of the UI elements are organized. There's the notion of an object to draw and a screen. And a screen has a bunch of objects to draw. And the way that the screen gets drawn is it goes through each object to draw and it draws the object. The way I make the various screens in my app is I have various methods which create and then return the various screens. The way synth works is that synth actually generates all the sound that you hear in the program. There are 4 wavetables which are the building blocks of the sound, and a synthesizer has a frequency and various variables which help it know how to actually create the sound. And the way the sound generation works is there's this one method called getAudioData, which returns 1 buffer of audio data. It has to do it in a way where first it creates 1 buffer of full-on output data of the wavetable that the synthesizer is currently set to, and then it goes through and adjusts the volume of it as according to its current state as to whether or not it is creating a strike at the beginning of the strike or at the end of the strike, which is represented by this amplitude control coefficient. And we do an exponential decay on the amplitude of the note. Then we see everything comes together in app.py. We're using synth to create our 5 instances of synths. They're going to be the green and blue notes, the red notes, and then the notes that the user plays. This is how we interact with synth, and then in order to interact with the app UI, we make all the various screens. So we use the UI to get all the different screens, and then when the time comes when the user clicks on them, we will add them to a list which will have all the current screens, and that is app.currentScreens. We'll have various state for the app, and we also interact with PyAudio by initializing the audio stream and using this audio callback function to actually output the audio data. We also have an internal timer. We know the amount of time that this callback function takes, and we increment an internal timer variable by this value each time this is called. And this is actually a very exact way of keeping track of the time, and we use this because we know how long each red note is, and we compare this to that value every time we want to test if we need to play a note. Additionally, all of the screens have a variable called event control, and this is how information is passed back and forth, how we update state between the app and the app UI.